topic is Congestion Control, fourth module topic of Computer Networks. And we have Mr. Dilip VK for handling today's session. He is working as Assistant Professor, Computer Science Engineering Department, LBS Institute of Technology for Women, Trivandrum. Mr. Dilip, a BTech graduate from LBS College of Engineering, Kasaragod, and has a Master's in International Business from 𝐂𝐨𝐧. MTech in Computer Science and Engineering from NMAM Institute of Technology, and he is also pursuing his PhD. He has an academic experience of 16 years and has paper publications in various journals. And his area of interest includes cloud computing, information security, mobile communication systems, and so on. We're extremely glad to have Dilip sir for this session. On behalf of ASAP ASDC Division, I welcome you, sir, to deliver today's class. And on this note, I would like to welcome all the attendees to the session. Let me conclude this introductory part by giving the outline of today's class. The entire one hour session will be divided into 40 lecture session and 20 minutes of question-answer interaction respectively. And during the interaction time, students may use the question-answer chat window by clicking raise hand icon near to your name. All the students are requested to maintain a classroom decorum throughout the session. Dilip sir will be available online throughout the session for this 1 hour. So you may please start the session.
Good afternoon all. Included in this session are general principles of congestion control, congestion control in virtuous circuit subnets, congestion control in datagram subnets, and different methods for congestion control. And here, in order to starting what is congestion control, we have to understand what is congestion or why it happens. So, general definition for congestion is it's a stage occurring in network layer when the message traffic is so heavy that it slows down network response time. So it is a traffic problem. You can merely understand it as a traffic problem. What is a traffic problem that we know? Because in Kerala, all the traffic routes are congested, and we are facing several traffics in between our journey in Trivandrum or in Kerala, different parts of Kerala. So the meaning for the traffic in network. In moving vehicles and people, here the moving of packets between the source and destination, between the nodes, different nodes of the network. So in simply we can define congestion as a state occurring in network layer when the message traffic is so heavy that it slows down network response time. So there are different layers in network. So here we are describing congestion as a part of network layer, and in network layer there are different routes. There are several packets are sending and receiving, and through the packet moving there will be we are expecting a response time which is we should be handled for a particular node, particular receiver. But here response time is becomes slow, or it slows down from the actual speed. That is the case, or that is the result of congestion. Now, what are the effects of congestion? Congestion means it making delay between the traffic or delay between the packet moving. So, how the delay affect the situation means, as delay increases, performance decreases. That we know, because we are expecting whatever the files we are sending, that should be reached in a within a particular time. But in between there are delay in the traffic means we will reach slowly, and that will affect our performance. Considering we are attending an interview or we are going for an interview, but due to the traffic, we cannot reach the correct time, exact time. Interview time is 10 o'clock, but we are reaching 10 or 10:30 or 10:45, etc. That makes a negative impact for us before the interview panel. Similarly, we are sending some data means, or we are transferring some file means, it has to reach the destination at the exact time, or at what purpose we are sending the files. According to that purpose, the packet should be reached in the destination. But here, or effect of ingestion, or because of congestion, delay, there will be a delay, and that delay decrease of performance. What we expecting from the file transfer, that result is not obtaining for the sender. So that is the case. And continuously, if delay increases means we will lose the packet. Sometimes we lose the packet because for every packet there should be a expiry time for a packet, or time to leave time for a packet. That we already studied. So time to leave expired means the packet is lost and we have to retransmit the packet. So retransmitting the packet, which will again makes the number of packets increases and making the situation very worse. And here we are considering the internet means all there is a queue of internet, always data transfer between senders and a large number of transferring some files through the network. We are sending some or we are listening to music, live music, or we are considering some video conferencing situations. In all cases, there are large number of packets are sending. This large number of packets are considered as a queue of packets. Packets are passing one after the other, and the transmitting nodes are constantly adding packets because we are deciding a data transfer means there is purpose. In order to complete the purpose, we have to pass several or large number of packets, and these packets are continuously sending. That means a queue of packets, and after receiving successfully, the packets are receiving successfully means we are removing the packet from the queue. Which is the destination? The destination will remove the packet from the queue, and all other packets which are not intended for that particular receiver will pass or forward through the network. That means again there is a queue exists, but we are removing some packets which are reached in the destination. And here we can consider the situation. There are too many packets are present in the queue. For every, we are considering the capacity as sometimes as a bandwidth, sometimes the buffer size, etc. If we have large number of buffer size, we can store large number of data. If we have a high bandwidth means we can send a large amount of data through the network. And that means, considering a network, there are large number of packets are sending from different senders, and it will be reaching different destinations. And here it makes a large number of packets are currently passing through the network routes, and constantly transmitting nodes are pouring packets at a higher rate than receiving nodes. This is also another situation. We have a sending node and a receiving node. Sending node have high buffer capacity and a high capacity router, and the receiving node is not at all that much faster routers. That means the sender will send the packet as usual, but the receiver cannot accept or cannot receive the packet as such. This also makes large number of packets are passing through the nodes, and this degrades the performance, and such a situation termed as congestion. So this is the situation where we are defined it as congestion. That means large number of packets are sending from one point to another, and that packets are moving from one end to another. In between, the speed of the nodes are important, capacity of buffer size is important, and because of the lack of these situations, several packets are moving through the same network. That makes the flooding situation that degrades the performance, and which is termed as congestion. We are sending some packets. In normal case, there is no such a problem of congestion. But for every network, there will be a quality of service. We can term it as QoS. Every network has a maximum packet size. Every network has a speed of a limited speed or a bandwidth. According to the quality of service, only a subnet can send the package, and that will limit the maximum carrying capacity of the subnet. That is shown in the graph, and we are reaching a maximum. The packets are perfectly sending. There is no undesirable situation is there. But again, the packets are sending, and the delivering packets is not much in the same speed. Means there are large number of packets are waiting for the delivery, and that means we are crossing the maximum carrying capacity of a network. This will degrade the performance. There we can lose some packets, and according to the loss of packets, there need a transmission that again makes the capacity maximum, and it will degrade the performance. That graph shown in the figure. The first one is the perfect match. Second is a desirable situation, and third means carrying capacity increases, means that subnet cannot accept more packets, but the sender again sending some packets. That means the performance will be degraded due to losing of packets. And what is the objective of congestion control? So anyway, congestion is not making a positive fact for the network, or positive result for the network. There will be some negative points that we already explained. So we have to control the congestion. So we have to term it in a single sentence. The objective of congestion control. What makes the congestion control, or what is the need of congestion control? To maintain the number of packets in the network below the level at which performance falls off dramatically. The previous slide shows that there is a maximum carrying capacity for every subnet. That is the stage where the performance will be in the peak, and we are increasing the capacity. We are again pouring packet to the subnet, means it will cross the maximum capacity, and thus there is thus leads to the loss of packets, and hence the performance fall dramatically. So there we have to maintain that the number of packets never crossed the maximum capacity. If sometimes it may cross, means we have to reduce that the maximum level. So that is the objective of congestion control. We have to control congestion. Sometimes we can avoid the congestion. That is another part. But sometimes the congestion will be there. So we have to reduce using some feedback mechanism. Causes of congestion. Some points. Here we are noting 3 points. The first one is insufficient memory to hold these packets. That is first case, because every node we are considering a subnet, means it consists of large number of networks, and the networks are connected through different connecting devices such as routers. So if considering a router, if it has a sufficient memory to hold all the packets moving through that network means there is no chance of congestion. So there should be a sufficient memory size every router. So there is a question from there because can we increase the memory? Can we increase the memory? Or can we increase the capacity of the buffer? But the problem is, if we increase the capacity of the buffer, there are large number of packets will be in the buffer. From the buffer, one after the other, or there will be a queue maintaining, and one after the other, the packet will be sent to the next node. So we are storing all the packets to the memory, but that forms a large queue, and every packet have their own time to leave. So before it will be forwarded to the next node, the time to leave or time or lifetime of the packet will be X. This will make retransmission. So we cannot increase memory or buffer capacity in an unlimited manner. There will be a limited capacity. So that's the case. Second one is slow processes also cause congestion because the sender router will be there and receiver router will be there. And sender router here it contains a fast processor, but the receiver router may have a slow processor because every router related to different network. So there will be a network which is recently established is there. Some network may not be established recently. So there will be a mismatch between the processors. The new processors will be fast or high speed processors, but the old network nodes will be slow processors. So it will make again the problem for the packet flowing. The faster sender will send large number of packets, but the receiver processor cannot process all those packets in the same speed. So this may lead to congestion. And third one is low bandwidth. Nowadays we know we have a large number of capacity bandwidth offered by different service providers. That is not in the case at the initial time. There is a bandwidth problem. So that is also affecting the packet traffic. And what are the general principles of congestion control? We are moving to the next section. That is, there are two approaches. Mainly, there will be two mechanisms. First one is open loop mechanism. Open loop mechanism. And second one is a closed loop mechanism. Open loop mechanism means that is not in our aim. That is, it should be solving the congestion problem by making a good design of network. That means when we are establishing a network, establishing subnets, before that we are identifying that this network may lead to congestion in future. So in order to avoid the congestion, we have to maintain high capacity processors, high capacity routers, high capacity network devices to establish the network. Accordingly, we can solve the problem. That is, we are making a good design. In order to avoid the root problem, we are making a good design. Accordingly, we are resolving the congestion or we are controlling the congestion. That is the open loop concept. And the second one is closed loop concept. This is due to or because of feedbacking. Feedbacking means already we are designed a network, but in between the network, large traffic, and this large traffic may make congestion. Then according to the feedback, there are several nodes, senders are there, receivers there. We are forwarding the packet means in between a sender and receiver, there are large number of forwarding routes are there. So every route can understand whether accordingly they will make some feedback to the sender, and according to or using that feedback we are maintaining the data flow. So that is the concept of closed loop concept. And the closed loop concept has three approaches, or the approach has three parts. So the first, monitor the system. We have to monitor the whole time. Then only we can detect when and where congestion occurs. We are looking on every node, every router, every network device of the network, and every juncture we are identifying that there is a chance of congestion. We are accordingly responding, positively responding. That is the monitoring concept. And after monitoring, we are identifying the congestion situation, or we are expecting a similar situation. We are passing information to where action can be taken. Sometimes action can be taken only at the sender. In between nodes, we can solve the problem, or there will be some sender points in the whole traffic. So we are passing information to these points. And third step is adjust system operation to the problem. If large number of packets are receiving at the receiver side, means the sender should make slow the sending process, or the sending slow but the receiving part is in a high speed manner, means accordingly, or any other problem, a parallel route is there, so accordingly we can make some adjustment. Accordingly we can resolve the congestion and control the congestion. And this is general division for open loop and the closed loop concept. In open loop, described it as it is related to good design. So good design means it can, or the design of a network can be controlled by either the source part of the packet or the destination part. They can decide what should be the design material or designing things that it has to ensure to avoid congestion or to control congestion. Similarly, the destination also can make some decision. Accordingly, it can the situation, the congestion. And the second type is closed loop, because here the congestion already happened, so there we are getting some feedback, and the feedback getting is of two types: either it reaching explicitly or implicitly. That means explicit feedback means once a node identified that there is a chance of congestion, it will use some explicit mechanism to inform about congestion. That is explicit feedback. Implicit feedback means when the node knows, the node itself act as a controller, or itself act as a congestion control, or it itself implement a congestion control mechanism. That is the implicit feedback concept. And I already explained that congestion occurring or congestion term is related with different the network. It may there are several measures related to congestion in transit. There are several measures related to congestion in data link layer, but here we are focusing on network layer congestion prevention or policies. We know about the network layer. We have two types of network or switching. One is virtual circuits and another one is datagram subnets. Virtual circuit subnets and datagram subnets. In virtual circuit mechanism, there will be virtual circuit. We are initially establishing a connection between the sender and receiver. That established connection is known as virtual circuit. Congestion control in virtual circuit subnet means we are preventing congestion in to use a mechanism, to use a a mechanism known as admission control. That is the once congestion is signaled, no more virtual circuits are set up until the problem goes away. We have maintained virtual circuit, or we can whatever the capacity of a network accordingly, whatever the capacity of a what is the capacity of network bandwidth, accordingly we can plan large number of virtual circuits. And here we are using a mechanism to prevent congestion, that if there is a chance of congestion, we are controlling the newer virtual circuit. We are not creating new virtual circuit or preventing data transfer through a established virtual circuit. Once congestion has been signaled, no more virtual circuit. That is the case. Admission control means we are not creating more virtual circuit at a time. And here, no more virtual circuits means there is a chance. So we are new virtual circuit means we are lost some option to reduce the load of current virtual circuits. So because of this case, we are not making no more virtual circuit. That is the case. And example is original telephone system. And alternative approach is to allow new virtual circuits, but carefully route all new virtual circuits around the problem areas. Another technique is used to reservation system that we will study later. And the first approach is alternative approach or alternative route. We are trying to get an alternative route for the congestion. That is here already the figure A shows that there is two virtual circuit between A and B. A and B, there is a two virtual circuit, but both virtual circuit showing is the star symbol showing there is a problem, congestion problem, and we cannot use those routes for the next packet sending. So we are redrawing this. We are new spanning tree. I think I know about the spanning tree concept. In the routing problems, we are using a spanning tree concept in network computer networks. And here already we are making a spanning tree. Using the spanning tree concept, we are identifying virtual circuit. So initially there are virtual circuit, but the subnet is congested. We are clearing two virtual circuit which leads to congestion, and we are redrawing the subnet, and accordingly we are identifying a new route which has no problem or no relation to that congested node. Here I think two sides, and in the first case there is a particular node which shows, and the second node also another particular node which leads to congestion. So in the figure B, we are avoiding that two points, and without touching that point, we are redrawing a new path, and that new path will be assigned for the extended traffic. So using this mechanism, we can eliminate congestion. Next is congestion control. There is a limit in virtual circuit, because virtual circuit we are maintaining the established connection. Some problem already shown in the established connection, we can stop that data transfer through, and we can establish a new drawing or new connection. That's only the solution. And next we are moving towards the datagram subnet, congestion control in datagram subnet. Each router can monitor the utilization of its output lines and other resources. In datagram subnet, each router can monitor the utilization of its output lines and other resources, because in datagram subnet there is no connection establishing. It is analogous to the postal service. when we are using a postal service means it is not similar to telephone connection. Telephone connection it is similar to virtual circuit. We are establishing a connection and then making a call. But in postal service, there is no such a connection between sender and receiver. Here, sender only sending the packet with an address. In postal system, we are writing the address and just posting the parcel or the letter. Similarly, in datagram also, we have a destination address, and with that destination address, the packet will be routed forward to the network, and it use convenient routes. There will be some mechanism, routing mechanism is there, routing algorithms are there. Accordingly, it will choose shortest path, or if the shortest path have high load means the next to shortest path, etc. It will select a route. Accordingly, it will send the packet or forward the packet from one node to another. Here, each node can monitor according to closed loop policy. Every router, each router can monitor the situation. Accordingly, it can act. That means we are considering for every node there will be a point, warning point, or we can consider a ratio. We can consider a ratio or a threshold. The number of packets or the number of packets and processing of the packets make a ratio, and that ratio exceeds a threshold. We can maintain a threshold for every node. If that ratio crosses the value, it enters a warning state. For every node, there is a threshold, and there is a ratio between sending packet and processed packet, or receiving packet and processed packets. And accordingly, that value, we are calculating the value, that value crosses the threshold means it enters a warning state. And the terms indicated DECnet or framelay, that are terms which are using. If we are studying the congestion control detail, we have to take the aspect of some performance mechanisms also. But here we are not considering that situation. Here we are only dealing with the mechanism, just control algorithms. What are the control algorithms we are following in congestion control? So here mechanism is that there is a threshold concept, and the threshold crossing means, or threshold reaching means, it's a warning state. After reaching the warning state, the nodes between the sender and router will take some decisions, and accordingly they will inform the source. They will inform the source route using a acknowledgement packet. That is the mechanism. That is the first mechanism. That is, we are controlling according to the information. Using that threshold value or acknowledgement. Using acknowledgement, we are solving the situation. For every router, there will be a threshold value for the sending and receiver, and that ratio reaching the threshold means that is the warning state. At the warning state, the particular node will indicate the warning using a warning bit in acknowledgement packet, and that packet will send to the source. And after receiving the acknowledgement packet by the source show that, or source get an idea that there is a warning. So that means there is a chance for congestion. So accordingly, the source will decide the flow, decide the data flow or packet flow. That is the case. That is the first mechanism. That is acknowledgement mechanism. The approach is send a choke packet. So the first case is warning bit. We are sending a warning bit acknowledgement packet. So there the problem is every which identifies the warning means, or after reaching a threshold value, more packets received in the node, every node will acknowledgement packet. So all the acknowledgement packet will be passed through the same network. That again makes some losing of data. So that's the problem with this acknowledgement situation. So we are preferring another approach. That approach is known as choke packet mechanism. Another choke packet mechanism. And here the node which identifies the warning, the situation of congestion, it will send a choke packet back to the source. Packet will inform the source that it has to slow down the packet run. It has to reduce the sending speed. So when a source gets a choke packet, it is supposed to slow down its transmission rate to by X%. There will be some criteria, some conditionality that once it receives a choke packet, it has to reduce the speed. It has to reduce the transmission speed. That will be when we are using binary mechanism, that should be in the half of the speed. Initially, it has 1 second. After getting the choke packet, it divided into 0.5 seconds. Set to data speed 0.5 MB, MB, that much data rate, that particular data rate. So that rate will be reduced because of this choke packet. So the particular node which congestion has to send the choke packet. That's the situation. So that case we can shown in the choke packet technique. It's a closed control technique. It can be applied in both virtual circuit and a datagram subnet. Each router monitors its sources and the utilization at each of its output line. Every router monitors the sources. That means every router has its own threshold, and every router has to check whether the level reached in the threshold. If that threshold value reached means that particular router will generate a packet. That is threshold set by the administrator, and whenever any of the resource utilization crosses this threshold, and action is taken to curtail down this. For that purpose, that particular router will create a choke. That choke packet is a warning situation, or it identifies the warning stage and sends the choke packet back to the source, giving it a feedback to reduce the traffic. So whenever the choke packet in the source, it will reduce the traffic. That is the rule. And the original packet is tagged so that it will not generate other choke packets by other intermediate router. So the original packet just forwarded to the next router, and in that case, in the header, that particular packet contain a bit which is shown that packet already in the previous route that already generated a choke packet. Hence, we can further generation of choke packet from the same packet in other router nodes here. So it means that the first router is the only one that sends choke packets. Normally there is a doubt that once a router identifies there is a chance of congestion, and after it forward the actual packet, it send a choke packet, and that the sended packet or send packet will forward to the next router. That router again identifies there is a chance of congestion, means it again generate another choke packet. So there will be a large number of choke packets in the network. That itself increase the congestion problem. So to avoid that one, once a packet generated or a packet become the point for a choke packet, that packet marked with a bit in the header field, and that hence ensuring that particular packet never generate another choke packet during that particular choke packet period. Okay. Then when the source host gets the choke packet, it is required to reduce down the sent out to that particular destination. From a particular destination, it received a source received a choke packet. That means it will reduce the speed to that particular. It will have packet, and that packet will be observed, and whatever the packet passes through that particular node which is generated the choke packet, and the speed of those packet flow will be reduced. receiving the choke packet, the source reduces the traffic by a particular fixed percentage, and this percentage decreases subsequent choke packets are received. So every receiving choke packet, the source reduces the traffic further by a particular percentage. Sometimes it is in the opposite to exponential way. I think exponential back off. That is, initially there is a speed of 16 and then 8, then 4, etc. That is the mechanism following by the source. This is the case, and start with the packet, P sending packet to Q, and P sending in between not conversion, but when it receives Q, there is a heavy flow. Q difficulty to accept the packet. At that time, Q will generate a choke packet. Q will generate to P. The choke packet and the data flow between P and Q continues there. In between, Q sending a choke packet to P. So, P, there is a congestion situation. So, there is a heavy flow. So, P, after receiving the choke packet, P will reduce the flow and continuing the packet sending towards Q. And initially, reduced flow will reduce the congestion Q. That is the choke packet technique. Problem we have facing is at a high speed or long distances. Here only only 3 nodes P and in between node and Q. But that is not in the real situation. There will be large number of nodes in between a sender and a receiver. So once there will be 25 nodes in between sender and receiver, and the receiver feels some congestion. Because of that, that receiver sending a feedback, a choke packet to the sender, means before reaching the large number of further packet sending between sender and receiver. That's the problem. That is the disadvantage of this choked packet mechanism. So, in order to solve this problem, we are advancing or we are modifying the choke packet mechanism, and it leading to some complex situation. The problem faced by choke packet mechanism, that is known as hop by hop choke packets. In this approach, sending packet to receiver, and a particular point receiver feels, or any node in between the sender and receiver identifies there is a congestion situation. Time the that particular node will send a choke packet, and choke packet will sent by a particular node, and that will be reached in the the node just before that particular congested node. The same time, it is not the source node, but the node just previous to the congested node, that node itself reduce the case. Hop by hop choke packet means that is the case. That is, node which receive choke packet will reduce the packet flow. Hence, we can avoid flow between sender and receiver before receiving the choke packet. That is the modification happening in hop by hop mechanism. Here the diagram shows first one is normal choke packet mechanism. Second one is hop choke packet mechanism. Here A to D. So D identifies. So D sending a choke packet just previous node, and the previous node itself responding to that choke packet by reducing the flow and further reversely forwarding the choke packet to the source. Packet again receiving and at another intermediate node, that also reducing the flow. That is the concept. Hop by hop mechanism. So we are already covered one mechanism that is known as choke packet mechanism. Another mechanism is acknowledgement mechanism. Acknowledgement packet, then the choke packet mechanism, and a modification of choke packet mechanism that is known as hop by hop mechanism. Hop by hop packet mechanism. This is load shedding. It is also a technique which will use congestion. What do you mean by load shedding? We already know about the term load shedding. Power cut and load shedding in KSEB, related to KSEB or electrical load shedding. That means we are shedding the load. The load will be reduced because of problem expecting because of the high load. So we are shedding the load. Here also, large number of packets, the congestion means large number of packets are receiving at or buffering at a particular point. They are feeling a congestion mechanism, high traffic mechanism. So in order to avoid that, we this load shedding. Load shedding means router drowning in packets, just pick packets at a random to drop. We are dropping the packets. That is the load shedding. 10 packets are sending. That is the threshold value. So after reaching the 10, the receiver will, after receiving 10, further packet received there means the receiver will drop. That is a load shedding. Load shedding. There are two types of load shedding. First one is wine, another one is milk. Because of this properties of wine and milk, terming the policy. Wine means the old will be age for that wine means that is the good wine. Newly made wine is not. That is the property of wine. In the case of milk, recently got milky good, but further time duration means the milk will become damaged or milk become accordingly. In wine policy, we will drop old packets, drowning packets, it will discard packets by dropping new incoming packets, not old packet. We are keeping the old packets and dropping new packets, that is wine. In the case of milk, we are keeping the new one and old dropped. That is the concept. Wine means old one will be keeping and packets will be dropped. In milk policy, the old one will be dropping and keeping. So this is the load shedding mechanism. We have two policies, wine policy and milk policy. In load shedding only we are considering the dropping of extended packet or the packet size buffer reached the threshold. The after coming packet will be dropped by the destination. That is the concept of load shedding. Random early detection. Random early detection. The third strategy, that is some historical background is there. A popular algorithm for doing this is called RED, random early detection. Floyd and Jacobson maintain that concept, and here I think it need more of in the there is a queue of packet. When we are sending data from source to destination means there will be a queue building a queue between source and destination, or in between intermediate node there will be a queue, and for every node we'll calculate the average length, and we will the every node will identify the threshold, and the average queue length, that threshold line exceeds, average queue length exceeds the threshold means the line is said to be congested and action is taken. That is the pre-work of the RAM. Since the router probably cannot tell which source is causing most of the trouble, picking a packet at random from the queue that triggered the action is probably as good as it can do. Clear? That is the case. That is, router probably cannot tell which source is causing. So here, one to send is choke packet. Another case is discard the select packet and not. So according to the observation, the receiver will make a mechanism early, because we are reaching the threshold, or we are just touching the threshold. At that time itself, the router think about the problem, and accordingly the source will notice lack of action and take action. Clear? Acknowledgement from the part of destination, and sometimes acknowledgement, not getting acknowledgement means it is losing some packets. So the without informing the sender knowing that there are no acknowledgement from the part of some packets, so it identifies destination point or any intermediate node. At that case, the source will respond. Without any choke packet, it is identifying, because this is the implicit concept. Sending a choke is an explicit concept. By identifying the choke packet, the source can reduce the speed. Here, without informing the source, the receiver itself discarding the packet. Accordingly, there is no acknowledgement for that packet towards the. Because of this identifying this loss of packets, source will decide or source will identify that there is a congestion occurred in somewhere. So accordingly, the source respond by slowing down the process. This is the solution in random early detection. Congestion control mechanism is jitter control. Mainly for audio video applications, sound video applications. So jitter means the varying delay between the packets. So due to jitter control, we are maintaining the jitter as a constant. So accordingly, we are keeping the audio and video packet in the buffer, and accordingly, the jitter can be bounded by computing the expected transit time for each hop along the path. When a packet arrives at a router, the router checks to see how much the packet is behind or ahead of its schedule. This information is stored in the packet and updated at each hop. Accordingly, it will maintain the delay, or accordingly it controls the jitter, and accordingly it makes the schedule. This is the concept of jitter control. Jitter control needs a buffering concept. Buffering means more memory concept is needed for jitter control. So these are the 4 congestion control techniques or congestion control algorithms we are using in a computer. Up to this, congestion control and congestion control algorithms. I think the time for question answers. If you have some doubts or any clarification needed, I'll be here and I will give the answer.
One question is there.
Okay.
Which is the better congestion control technique among all the 4 explained?
We cannot. I think we cannot differ or we cannot define a mechanism as a better or not. It is depend on the network, what using, or whether that network always going for the congestion, or only sometimes, or we are going for some only the audio applications, only video applications, etc. Accordingly, we can decide which will be the better.
Okay, sir. And so there is one more question. What happens choke packet is lost due to congestion?
Choke packet, again, there will be the it will reach the extreme congestion. That is the case, because after making or creating the chalk packet, there will be an expiry time to leave for the chalk packet also. So within that time, there is no response from the source part or the same speed the data coming from source, means there is some problem for the jitter, and again some problem for the chalk packet. So the node will again send the chalk packet. If the congestion node becomes solved, means again it will resend the chalk packet. That's the solution. Okay.
And now, sir, next question is, please
Okay.
explain congestion policy using table. That's not clear actually. The question is like this: please explain congestion policy with an example, using an example.
Using an example. Congestion policy with example means I already giving some ideas on different algorithms. That algorithms, when we are sending a chalk packet, or large number of packets are flowing from source to destination, there will be intermediate nodes, and once the packet reaching a particular intermediate node, and there occurring a chance of congestion, means that particular node taking one of the algorithm or one of the congestion control mechanism, and accordingly it will act. But example, I think whether there are two type of, or policy means there are three layers are mainly handling congestion: data link layer handling congestion, network layer handling congestion. All the layers their own policies, because their functionalities are different. Data link layer have some functionality; it is directly connected with the physical concept, and transport layer have mechanism which is directly deal with the higher layers, and in between there is a network. Here we are dealing with the network layer congestion prevention policies, and the policies are one is virtual circuit versus datagram, one concept. Sometimes network will be a virtual circuit connection is there, sometimes a datagram subnet is there. So whether we are implementing this prevention policy in a virtual circuit connection, there only we have some admission policies. There are the different number of virtual circuits are currently using, but all those virtual circuit congestion, so we have to stop that, or we have to break that circuits and newly arrange a new virtual circuit for the connection. That is the solution. And whether check the network is not the virtual circuit, it is a datagram case or packet switched network. In that case, we are using the other mechanism like chalk packet mechanism, or jitter control mechanism, or that load shedding policy, or the random early detection policies, according to the network. That's our policy. Service policy. How we can maintain the queue? There is a fair queuing is there, weighted queuing is there, different details are there. We are not going for that particular detail. I think that details are not covering with this 1 hour session. And packet discard policy, already I told some packet discard policies, like packet second one, that is wine policy and milk policy. Both are packet discarding policies. In wine policy, we are new packets are removing, and I think in that case we can give sometimes when we are showing some, there we can use this wine policy, because initial file should be, we have to seen first, then only we can understand. There we need the wine policy, but in we are just sending some files. No, nothing more important for that file, means there we can use this milk policy. We can keep the new one, and old one will be removing. That is the packet discard policy. Then routing algorithm, when we are choosing a particular routing algorithm itself prevent the congestion. And packet lifetime management, again we are maintaining a large buffer, and that and the lifetime will be increased for every packet we can maintain, or we can prevent the congestion with a larger buffer. So accordingly we can choose the mechanisms. I think example is she's expecting like that. In wine policy, the policy we are one is movie or songs. We will prefer the milk policy and wine policy, and for the file transfer we will this milk policy.
Okay, sir.
ആദ്യം വീഡിയോ എന്നുള്ള ഒരു ലിമിറ്റേഷൻ ആണ് നമ്മുടെ മുമ്പിലുള്ളതെങ്കിൽ അത്യാവശ്യ കാര്യം കൺജഷനുമായിട്ട് ബന്ധപ്പെട്ടിട്ട് കാര്യങ്ങൾ സ്പെസിഫൈ ചെയ്തിട്ടുണ്ട്. അപ്പൊ അതിൽ എന്തെങ്കിലും ക്ലാരിറ്റി കുറവോ എന്തെങ്കിലും മിസ്അണ്ടർസ്റ്റാൻഡിങ്ങോ വന്നിട്ടുണ്ടെങ്കിൽ അത് എന്നെ നിങ്ങൾക്ക് കോൺടാക്ട് ചെയ്യാം. എൻ്റെ മെയിൽ ഐ ഡി �ദിലീപ്@gmail.com എന്നാണ്. അപ്പോൾ നിങ്ങൾക്ക് എന്ത് ഡൗട്ട്സ് ഉണ്ടെങ്കിലും ക്ലാരിഫൈ ആവുന്നതാണ്. അപ്പോൾ എല്ലാവരും ഈ ലെക്ചറിങ് അറ്റൻഡ് ചെയ്ത എല്ലാവർക്കും എൻ്റെ പേഴ്സണൽ ആയിട്ടുള്ള നന്ദി അറിയിക്കുകയാണ്. താങ്ക് യു.
Thank you so much, sir. I would like to extend my sincere gratitude to Dileep sir for today's session on congestion control and technique. I truly appreciate you and the time you have spent to associate with ASAP for the online classes. And I thank all the attendees for being patient listeners. Once again, I thank you all. Thank you so much.